Hi students, I am going to talk with you today about our first video lesson. I'm giving this a try. I'm trying some different techniques. We'll see if this works. We'll see if it doesn't. We'll learn on the fly. I talked with my students today, and so I'm making the video for you about our science and engineering practices. So I will share a copy of this chart for you to put in your digital notebook. But for now, I just have it on the screen for you to see. We use the Next Generation Science Standards, and in those standards, they have something they call science and engineering practices. And what those are skills that scientists need to be able to do good science. But I would counter that they are skills that just people in society need to be critical thinkers. So things like asking questions and defining problems, developing and using models, planning and carrying out investigations, analyzing and interpreting data, using mathematical and computational thinking, constructing explanations and designing solutions, engaging in an argument based on actual evidence, and then obtaining, evaluating, and communicating information. I think those are all skills that a good citizen needs. So one of the things I really want to focus on this year, in addition to basic content, information, science things, is learning these skills, because I think these are the part of science that are going to benefit you most in your everyday life. So the first focus I want us to have is on this developing and using models. And so you know, a model, you should probably think about a fashion model, but there are lots of different types of models, especially in science. And so some examples that I used of those today in class, hold on just a second, would be a globe, which is a model of the Earth. It takes something that's very big and makes it a manageable size for us to see. It also includes lots of information that aren't actually on the actual Earth, right? We have country borders and latitude and longitude, city names, things like that. That type of a model allows us to not only see something that's too big for us to see normally, but also adds details and information that make ideas and things useful. So another example of a model is this. This is a model of an animal cell. This is something that's actually too small for you to see that we've made large. So the example of the globe, we took something big and made it small. This is something small, we made it big. So adjusting the scale to one that's easier to see is a reason to make a model. If you've got something that's very complex and you want to simplify it, that's another good reason to have a model. If you have something that you want to show the inner workings of, how pieces fit together. So basically, models are a way of better understanding something in science or in the world. There are lots of models, like model cars and model airplanes or crash test dummies that model accident crashes. Models are very useful. So we learn a lot through models. And so what I want you to do in your notebook is we're going to start making, hopefully all of you have a notebook, you're supposed to. We're going to start making informational pages about these science and engineering practices. So in your notebook, I always like to skip the first page because sometimes that one gets dirty or torn. So after your first page in your notebook, the next page, we'll label that with a number 1. The back of that page will be a number 2. And then this page will be a number 3. And so number 1, we'll put that heading about asking questions and defining problems. And we'll get to that one another day. Today, we're going to focus on developing and using models. So on that page 3, developing and using models. So scientists need to be able to use existing models, but we also need to be able to develop our own models to explain things to people. So a good working definition of a model is it's going to be anything, right, that represents ideas and explanations. So under here, if you'll write models represent ideas and explanations. So our models are going to explain how things work. Our globe explained how countries are laid out onto our continents, how latitude and longitude fit around the world. So they give us extra information that you wouldn't see by just looking at the object. And so examples of types of models would be diagrams. Those are things with information, arrows, pictures, words, drawings. If you had never seen a bird, but you could see a drawing of the feather colors and patterns of a bird, that would be giving you information about that animal. Replicas. If you've ever seen a model airplane or even the globe would be a replica of the Earth. It's designed to look like the original object, like in 3 dimensions. Analogies. So analogies are word models. So when you describe things by saying they're like something else. So I'm trying to think of a good example, because I can't do the one I did in class because it involved me moving around. I like to say that enzymes, which are special types of proteins, they work on their substrates, they change them in a way, and you can think of them like a monkey peeling bananas. You give the monkey a banana, he peels it, he knows what to do, he does the same thing over and over. He can only go so fast. You're gonna get to a point where it doesn't matter how many more bananas you give to the monkey, he's not gonna be able to peel them any faster. So that kind of is an analogy where you compare things to another thing. And you guys know about computer simulations. So those are examples of models. Now, no model is perfect. There is not the perfect model of anything, because if you had the perfect model of something, it would be just like the original in every way, in which case it would just be the thing. So then it's not a model anymore. No model is perfect. Models all serve a purpose. And in our class, we're going to be using models to help you show me what you understand about a system, or for you to kind of work through what you understand about a system, or to put together a model and they'll help you figure out something maybe you didn't know. But the first model that you draw is going to be called the initial model. Initial meaning first, like the letter in your name. And initial models show your understanding right now. If you don't know everything, that's fine. The initial model is to get everything that's in your brain right now out on the paper so that you can see what you know. I can see what you know. I can see what you don't know. Sometimes you see what you don't know. I've had students who they're drawing the door and they're like, oh, what do you call that thing? I'm like, well, if you don't have the vocabulary, explain what it does, and then we'll add that later. So your initial model can sometimes let you know, oh, there's a term I don't know. There's a term I need to know. I need some vocabulary. So initial models are good at showing what you know right now. There's not a right or a wrong. It's just how do you understand it right now? And so what I wanted to do was ask you to draw your first initial model to show me what you know about an object. And so I had to think of something common enough that everyone knew what it was, simple enough that everyone understands how it works, but complex enough that we can draw an interesting model. So what I came up with was a door. You all have a door in your house, somewhere in your classroom here at school. And so what I would like you to do, using the remaining space on your page, so don't draw it small, take up the space, put in as much detail as possible. And I would like you to draw on this page your initial model of a door and how it functions. So your drawing has to show me how a door works, how it functions, and all the parts it needs to be able to do that, okay? So your assignment for today is to draw this initial model of a door, take a picture of it somehow. You can take a picture with a phone, you can take a picture with the camera on your computer if you have one, and then I want you to submit that and turn that in. So I'm going to post this video and I'm going to post a place for you to upload your initial model of a door. I'm excited to see what you come up with. Bye. Until next time.